To balance the unbalanced system of unbalanced masses on multiple planes, the best scenario is that we can choose some balancing masses at some arbitrary planes at some radial distance from the axis of rotation. So the blue line represents axis of rotation, and also at some axial distance at the axis of rotation. To balance the unbalanced forces in case of multiple masses and multiple planes, there are few considerations that we have to keep in our mind. The first consideration is that we have to balance the forces and balance the couples. Couple is nothing but the moment. At first, we have to balance the couples. In balancing the couples, what we are doing, we have to choose an arbitrary plane in a way that it will cancel the couple produced by one of the balanced mass. Because in our scenario, we know the mass m1. If we know the mass m1, r1 is known, then we can have a known value of fm1. Also, mass m2 is known, the radial distance from the axis of rotation. The radial distance from the axis of rotation is known, therefore fm2 is known. Mass m3, the unbalanced mass m3 is known, and the radial distance from the axis of rotation is known, therefore fm3 is known. The only unknowns are the balanced masses b1 and b2. In case of couple, what will happen that the force produced by m1, which is fm1, has to be multiplied by the axial distance, such as this. So couple C1 is the force produced by fm1, the mass 1, into the axial distance L1. The couple at b1 will be 0 because this b1 is chosen as arbitrary plane where all the moments of couple will be taken. Therefore, movement around its own plane is 0 because there is no axial distance. As you can see, in case of m1, the axial distance is L1. In case of b1, there is no axial distance because this plane is taken on b1. By this way, one of the balanced force is, we are getting it away from our system. Away from our system doesn't mean that it doesn't exist. Away from the system means that in calculation we can avoid b1. Then couple C2 is produced by force of unbalanced mass m2, which is fm2, into axial distance L2. Then force produced by the balanced mass b2, which is fb2, into the axial distance L3. And the last couple is C4, which is the force produced by mass, the unbalanced mass m3, which is fm3, and the axial distance L4. So here are the couples.